now we need to actually take care of the collision detection. And for that, we need to be able to tell where exactly on the screen the sprite is rendered, of the sprite of the T-Rex. And we need to define like a collision box that we can use to detect collisions. So what we're going to do, is we're going to add a property of type rectangle and call it collision box. And it will actually only have a setter, a getter, which we will implement now. And this property returns a rectangle that represents the a box on the screen, a rectangular shape on the screen where the sprite of the T-Rex is rendered. So we can use that to see if the T-Rex collides with one of the obstacles. So here, let's return a new rectangle. And we will use this constructor here. We need to define x, y, position, and the width and the height. And for x and y, we can simply use the position values. And for the width, I'm going to pass the default sprite width and the default sprite height from the constants. And obviously, the rectangle constructor takes 4 integers, and the x and y properties of the vector class are floats. So we need to cast that to an integer. And I will actually, before casting it, I will round it properly to the next integer, like this. And maybe move this down a line. Maybe I don't like the way this is formatted, so maybe let's do it like this. Oops. There we go. Yeah. So now we have a property that we can use to check where exactly the T-Rex is rendered, including its width and height. Okay, so next, let us move to the obstacle class. Open it up here. And remember that we implemented an abstract property here that's also called collision box, for returning the same thing here, basically a rectangle that describes where on the screen the obstacle is rendered, and yeah, a rectangular shape on the screen that we can use for collision detection. And the subclasses of the obstacle class then provide an implementation of this property. But here in the obstacle class, we don't really care about how this is implemented. So we're just going to go ahead and go into the update method. And actually, we're going to go down here and create a new method and call it check collisions. Whoops. Like this. And then in the update method, we will call that method. And here in this check collisions method, as the name suggests, we're going to check for collisions between this particular obstacle instance and the T-Rex. And for that, we're going to first declare a new variable, call it obstacle collision box. And that'll be the return value of the collision box property. And another rectangle, which will be the T-Rex collision box. And we can get that using the T-Rex field and calling the getter of its collision box property. And luckily for us, the rectangle class, or actually the rectangle struct within the MonoGame framework already has a method that checks whether two rectangles are overlapping. And we can use that to implement our collision detection. So let's go ahead. If obstacle collision box intersects, and pass the TRex collision box. And here in the description, in the summary of the method, it says gets whether or not the other rectangle intersects with this rectangle. So that's exactly what we want. So if the collision box of the obstacle and the collision box of the TRex intersect, then apparently or obviously we have a collision, and now we need to handle that. And what should happen? Well, obviously we want to kill the TRex by calling its die method. Anything else? No, I don't think so. That's basically it. But now, again, this is an abstract property. We need to actually, in the subclasses of obstacle, provide an implementation for that. So let's move into the Cactus group class, go up here. And as you can see, we already did override the collision box property because we had to, since it's an abstract property in the base class. But all we do here is throw an exception, a not implemented exception, and obviously that's not what we want. Instead, we want to actually return instance of rectangle, whoops. And again, for the position, we can simply round the position values to the next integer and cast it like this. Whoops, I forgot to cast it like this. And for the width and the height, yeah, we need to be a little more specific, because remember that the Cactus groups can be of different sizes. So we can't use a constant value or anything like that. But what we can do is simply use the width and height of the sprite property, since that completely depends on the group size. Because we implemented that here. So in the constructor of the rectangle, let's pass the width and height of the sprite. Like this. And that'll be that. So now in the obstacle class here, when we call the getter of the collision box property, thanks to polymorphism, we will actually call the getter of the subclass, which currently is the Cactus group class only. We haven't yet implemented any other subclasses of obstacle. And here we simply construct a new rectangle and return it. And yeah, that's it. And now we need to we need a way to notify the game that the TRex has died, and that the game should switch into the game over state and render this new game over screen, stop spawning obstacles, stuff like that. And for that, we're going to use a similar approach as we did for the start of the game with this event handler here. We're going to implement a new event in the TRex class that is raised whenever the TRex dies. So basically whenever the die method is called. So let's go ahead here and create a new event using the event handler delegate. And let's call it died, like this. Then let's move down here. All the way down to the die method. And here we're going to implement a method that raises the died event. Like this. And we don't need any event arguments, so we're just going to pass an empty set of arguments like this. And now we need to actually raise the event within our die method. So let's go, let's say down here, let's say on died. So whenever the die method is called, the died event is simply raised, and clients of this TRex class can subscribe to the died event in order to be notified and then handle that event appropriately. So that's what we want to do. So let's go into our TRex runner game class, and let's see, all the way up here in the load content method, we already subscribed to the jump complete event. Now let's also subscribe to the died event using the plus equals operator, and here you can already see that IntelliSense suggests that we simply press tab in order to insert a newly generated method, which I'm going to rename. I'm actually going to remove this underscore and hit enter, and here it is. So we subscribe to the died event of the TRex class with this newly generated method. So this method, TRex died, will be called whenever the TRex dies. Now, what do we want to do then? Well, first of all, we want to set the state of the game to game over. Also, we want the obstacle manager to stop spawning obstacles. So let's call the let's set the isEnabled property of the obstacle manager to false. And then let's set the isEnabled property of the game over screen to true, so that it starts rendering the game over text and the button. And what else? What else do we need to take care of here? The state is set to game over. The obstacle manager is disabled. The game over screen is enabled. I think that's it. Since the speed of the TRex is already set to 0, I don't think we need to do anything in the ground manager. So I guess we can already test this. Oh, actually, we forgot one thing. We do create an instance of the game over screen and add it to the entity manager, but we forgot to set its position property. So let's position it correctly. And I guess we should go with for the X position, we should go with the window width divided by 2 minus I guess we have to subtract half the width of this sprite here. And we can get that by simply going into the game over screen class. And let's make this game over sprite width constant. Let's make it public. There's no reason to keep it private. It's a constant anyway. We cannot change it, so we don't actually break encapsulation or anything, so that's fine. So let's go ahead here and subtract that constant value, or half of it, right here. And for the Y value, let's go with the window height and just subtract, I don't know, 30. Guess that should be fine. Let's just try that. I think the collision detection should already work. let's go ahead, fire up the game. Start it. Let's run into, oh yeah, great. But this is way too low. Let's move it up a little bit. Oh yeah, I forgot to divide the window height by 2. Sorry for that. Let's fire it up again. But the collision detection itself seemed to work. Let me actually try to jump over the obstacle. Whoa. Okay. Okay, so the positioning of the game over screen seems to be okay, but I get the feeling that the collision boxes are a little too large, I guess. Let me restart the game. I think the collision is working properly, it's just that the collision boxes should be slightly smaller than the actual sprites. See? Did work. But yeah, the collision boxes are just too big. Let me see. So that works. But yeah, as you can see, it's a little off here. So let's play with those values a little bit. I guess we can have a little inset. Let's go back into the Cactus group class and just reduce the size a little bit here. So let's say the width and height values, let's reduce the width by, I don't know, let's have a look here. So normally the width of one of them is about 18 or 17. Let's reduce that by, let's say 5. Let's reduce both values by 5. Width -5 and height also -5. And maybe that'll work better for us. Start it up again. Still. That's still a little too big. So if we simply reduce the width, then that's not enough. We also have to move it slightly to the right then. Because if we simply reduce the width, basically what we do, if this is the, let's say this little outline here is the collision box. And if I just reduce the width by 5, the collision box will be like this. But we actually need to then move it a little to the right. But there's an easier way for us to do that. I believe that the rectangle struct actually has a method for reducing its size. So let's remove this here. And instead, we're going to go here, and say dot. I guess it's called Inflate. Adjusts the edges of the rectangle by specifying horizontal and vertical amounts. And I guess those can be negative. So let's just say here -3, -3. Does that work? Oh, it doesn't actually return a new rectangle. It actually changes the values of the. So we can't do that. Actually, let me highlight this line, then right-click, quick actions. No, I need to right-click the name of the property, quick actions, use block body. There we go. And now I will not directly return it, but instead I will store it in a local variable named box. And then say box inflate. And then pass -3 for both, for horizontal and vertical amount, and then return the box. It's a little strange that this rectangle struct is mutable. Usually structs should be immutable by design. So I thought actually that the inflate method returns a new instance of rectangle, but apparently it actually changes the properties of the current instance. So yeah, instead of directly returning the rectangle, we're going to store it in a local variable, then call the inflate method to adjust the size a little bit and then return it. So that should be fine. Let's start up the game again and test it. Let's run into it. Yeah. It seems okay. Oh, yeah, of course that button is not working. But that's what we'll do next. Let's test it again. Let's run into that little one here. Yeah. Seems quite all right. Or maybe not. Maybe I should also have an inset for the collision box of the T-Rex. I guess that would be fair. It makes sense. Yeah, let's do that. Let's go into the T-Rex class. Actually, first, let's not hard code the values here. Let's actually go up here and declare a new constants. Private constant int, and let's call it collision box inset. Actually, do it like this. So here I defined it as a positive 3, but then here I use the minus operator to negate it. Yeah, that's fine. Let's move to the T-Rex class and do a similar thing here. Where is it? There. Right click the name of the property, quick actions, use block body. Ooh, that's not nice. There. Rectangle box equals, whoops, like this. Return box, but before that, say box inflate, and let's go up here as well. Up here and say private constant integer collision box inset equals, yeah, let's also go with 3. Then here say minus collision box inset minus collision box inset, and there we go. Let's test it again. So now the T-Rex also has a slightly smaller collision box. That still seems fine. Let's fire it up again. I guess currently it's only problematic really for the large Cactus group. I think now it's okay. Let's give it just one more try. Yeah. So far, so good. Yeah, I guess I can live with that. I'm happy with it. Yeah. Okay. Okay, so now there's just one small thing bothering me here, and that is that we have a collision box property in both classes here, and what I want to do is provide an interface, even though we're probably not going to really use that, but an interface to generalize that. So what I mean by that is, let's go here into the entities folder, add new item, interface, and call it something like iCollidable. iCollidable. So that'll be an interface that describes any kind of object that can collide with other objects. And this interface will simply have a single property of type rectangle called collision box. Collision box. And that property only has a getter like this. So now we can have our two classes, the TRex class and the obstacle class, implement that interface like this. Oh, iCollidable, yeah. There we go. And the compiler is happy with it because we do provide a collision box property of type rectangle, so that's fine. And let's do the same thing in the obstacle class. There. Now I'm happy with it. That's a little bit cleaner of a design. So that's okay, that's dealt with. So let's see what we can do next. All right, I figure if we take care of the replay button in the game over screen now and implement that, then we already have a functioning game. We're not done with the game then. We still want to implement the other obstacle type, this little pterodactyl, and we also want to implement the clouds in the background and the stars and the moon and the day-night cycle. But at that point, if we implement the replay button, we do actually already have a functioning complete game. So let's do that next. And for that, let's go into the game over screen class. And here we need to basically listen to the mouse and check the position of the mouse and check if the position of the mouse is within the boundaries of the button, and if then the mouse button is pressed, we need to actually handle that and simply restart the game. So let's go ahead and do that, and let's see. I guess in the update method we could do something like mouse get state. Yeah, using the get state method of the mouse class, it's a static method, we can get the state of the mouse, just like we can do with the keyboard state. So let's say mouse state equals mouse get state, and now we can use that state to determine the position. And let's see. We do have the position of the button, and we also have the width and height of the button. So let's maybe go here and say define a new property of type rectangle and say button, call it button bounds, and that this property will return, let's go down here, return a new rectangle. And there's a constructor that actually takes 2 points, and I will use that. And I will go ahead and use the button position as the start point. There's a 2-point method in the vector2 struct. And then here I will pass a new instance of point, which is simply the width and the height of the button, like this. So we create a new instance of rectangle defined by 2 points. One is the position of the button and one is the width and the height of the button. And now we can simply go here in the in the update method and say if button bounce contains, then we can pass a point here, and that point will be the position of the mouse. Mouse state position there. So if the boundaries, if the rectangle that describes the shape of the button, if that contains the position of the mouse and the mouse state left button. Is that a Boolean? No. Let's see. How can I get the state of the left button? Left button has flag. Let's see, I haven't done this in a while. It returns a button state. Oh, I guess we have to if the left I guess button state is an enum, right? Yes. Let me take a look at it. Oh, see, the button state is either released or pressed. So we can simply here go equals button state pressed. So if the left button is pressed and the mouse position is within the bounds of the button, then we want to actually reset the game. And for that we need a reference to the game actually. So, I mean, we could implement an event here again, but I think we can actually keep it simpler than that by simply going here in the constructor and passing another argument of type TRex runner game class, TRex runner game. Let's call it game. And then go up here and add a new field, also of type TRex runner game. Call it game with an underscore, and then initialize that field here in the constructor like this. And now we can use this field to call a new method that we need to define. So we added a new argument to the constructor of the game over screen in order to pass a reference of the game instance here, and we store that in a field. But we need to first go into the TRex runner game class and actually provide a method that resets the game. And here obviously the constructor of the game over screen no longer works because we need to pass an instance of TRex runner game, and in this case we can simply pass this, which is a reference to this current instance of TRex runner game. Now let's provide a method, a public method, which returns a Boolean, and call it replay. And let's say if the state is not game over, then we return false. Or do we? I mean, I guess we could. No, no, no. I was just thinking. No. If the state is not game over, we can't replay, so we don't do anything. We just return false. Otherwise, we want to return true. But before that, obviously, we want to do something else. We want to. Let's see. We want to set the state to playing. We don't want to play the transition animation again. It only happens the first time. But we do want to set the state to playing, and we want to call the initialize method of the TRex. What else? We want to re-enable the obstacle manager. We want to disable the game over screen. And what else? And we want to set the score in the scoreboard back to 0. And I think that's it already. Let's move back into the game over screen class, and down here in this if block, let's actually call the replay method of the game like this. Yeah, I think that's it. Let's go ahead, play. And let's purposely run into the next obstacle. There we go. Let me try to click anywhere. Doesn't do anything. Let's try to press the button. And it seems to work, but the problem is that the current obstacles are not despawned. See, as soon as I click here, the TRex does come back to life and start running again, and the score is set back to 0, but the TRex immediately runs into the obstacle again because it's still there. This, see? I forgot about that. We need to actually despawn all of the obstacles currently on the screen as soon as we click this button. So let's do that. And how can we do that? I guess that's a responsibility of the obstacle manager, since, well, the obstacle manager is there to manage obstacles. So yeah. Oh, that's the ground manager. Obstacle manager. Let's go all the way down here, and within the obstacle manager, create a new method that doesn't return anything, and let us call it remove all obstacles. And this will simply we're going to loop over all obstacles, and we can get all of the obstacles with the get entities of type method of the entity manager, passing the obstacle type like this, and then we can say entity manager remove entity obstacle like this. And I guess it should already do the trick. So let's go back into the TRex runner game class here, and before we re-enable the obstacle manager, actually call its remove all obstacles method. Oh. Like this. And I guess this should do the trick. So let's start it up again. Run into it. restart it, and yeah, it works. But I think we also need to reset the ground tiles, because now when we when we click replay, the ground just, it doesn't reset, it just keeps, it starts moving again, but yeah, it doesn't look like we actually restart the game. Kind of, it just seems like yeah, it doesn't look like the ground is resetting, because it isn't. It just starts moving again, and it's, I guess it's okay, but it's not like in the original, and it's kind of weird. It took quite a long time for it to spawn new obstacles. That's weird. Why does it take so long? Oh, I guess it's because we need to oh yeah, we need to set this last spawn score property back to a negative value to indicate that no obstacle has been spawned yet. Okay, yeah. So maybe let's rename this. This remove all obstacles method, let's actually rename it reset. And in the reset method, we remove all of the obstacles, and then we, whoops, and then we say current target distance is 0 and last spawn score is -1. Because we need to make sure that the all of these values are also reset. But other than that, I think we're in the clear. And since I renamed it using this rename refactoring functionality, it's already changed here as well in the TRex MonoGame class when I called it. Yeah, and I guess that was it. Let's test that again before we take care of the ground manager. Whoops, there we go. Oh, that's another problem. We need to set the Y position again. But yeah, it seems like the problem is fixed. Yeah, I guess, hold on. I guess we can do that in the initialize method of the TRex. Let's go to the TRex class again here, and in the initialize method, I think we actually stored, in the constructor, I think we stored the start Y position here in a field. So we can use that to reset the start Y position like this. And this should fix the bug. Start it up again, jump into it, there we go, click replay, yeah, and now it's no longer floating in the air. Great. Ooh, it seems like the large group is almost impossible to get over. Well, I guess it is. Huh. But yeah, I don't want to spend too much time fiddling with those values. It's I guess you get the point, you get the idea, and you can play and adjust those values yourself. I mean the collision values and the speed values and things like that. Oh, that was clearly too early.